Hey kids, welcome to my kitchen, or really not my kitchen, but another friend's kitchen that I'm lucky enough to use and probably will never be invited back again. We are going to be doing all sorts of super cool science. I'm in this kitchen, you're in your kitchen, or hopefully some random friend's kitchen that you have. We're going to do all sorts of science with ingredients you already have around. We've got cornstarch, we've got some soap, we've got borax, all sorts of neat stuff. We're going to be doing science experiments right here together. Also, we're going to be going back and forth and seeing a live show. I'm so sorry I can't be there with you to give you a real live show, but I will be back maybe in the fall or next year, and we're going to do all sorts of really cool stuff. In the meantime, we're going to see some outside big show experiments that I can't do here, and some kitchen experiments that you can do at home with a parent or an adult or someone with a lab coat. So join me for some super cool science. Here we go. I've got to get my stuff. This is not my house, so I don't care. Okay, safety warning. What do you never play with? Fire. Who has seen a movie with a dragon? Only a few people. What do dragons do? They breathe fire. Okay, this is a cool movie effect. If you're making a movie with a dragon, but you don't have a real dragon on your movie set, use this stuff. It's called dragon's breath. Ah! That's really warm. Okay. Ah! Okay. Another great experiment we shouldn't try at home. This is, everybody say dragon's breath. This is like a podium or dragon's breath. Now, it's a little, here, I'll show you. Nothing in my hand right now. Can you guys see that yellow powder from where you are? Yeah. Now, here's your quiz. Theoretically, what would happen if I took this lighter? What's going to happen? This is where someone says, stop, don't do it. Oh, we're crying out loud. Somebody say, stop, don't do it. Okay, I'm going to do it anyway. But yeah, I appreciate you caring about me. Well, what would happen if I did it? It's going to burn my hand off. Is this a good idea? No. Thank you for telling me to stop then, people who care about me. Okay, here we go anyway. 3, 2, 1, and... What happened? Nothing happened. It didn't burn my hand off. How come it's not working? Who knows the answer? Say it if you know. You don't know? You need 3 things for fire. You need fuel, this stuff. You need heat, this stuff. And you need, everybody say oxygen. Take a deep breath. Let it out. What do you breathe in? You breathe in oxygen. We need oxygen to live, and so does fire. So if you just do this, no oxygen can get to it. But if you just add oxygen, then it works just great. Okay, the first thing we're going to do is make a polymer. Everybody say polymer. Thank you, disembodied heads in my studio audience, which may or may not exist as far as you know. You can play along at home by saying polymer. A polymer is a bunch of molecules that are linked together in a chain like a web. We are going to make one right now so you can see what I mean. Now, we have our first ingredient, which is, everybody say borax. Borax is kind of weird soap type thing. It's in your laundry room. No one really knows what it does. It does a bunch of things, including this. My next ingredient is, say water. Water, okay. So, by the way, in chemistry, generally, you measure your ingredients. Today, we're not doing that. We're just going to dump stuff in. It's going to be nice and fun. And you might have some mixing utensils. We've got mixing utensils right here. This is hands-on science. I want you to enjoy every bit of this by getting your hands in there. Let's see. Dump some water in there. Dump some borax in here. Now, what you want, you mix this, is going to be a sodium borate solution. Now, a solution just means we're just going to mix it until it stops dissolving inside the water. So I can feel it. Normally, it would be clear, but it's a little bit grainy because I just kind of dumped way too much stuff in there. Now, that's our first part of it. Got our borax solution there. Our next ingredient is, everybody say glue. Yeah, so we've got Elmer's glue. Any white glue, any kind of school glue works for this. So, once again, we're not going to measure, just going to dump stuff in. And, that's probably perfect. Who knows? Now, take your measuring utensil, go in there. Now squeeze it underwater. You want to squeeze it underneath. Oh, yeah. Now what you can see, well, you can't see, but you can feel it. It's turning into a polymer. All those molecules are linked together. Now I'm squeezing it underneath the water surface, because if I took it out and squeezed it, it would explode and get all over this nice kitchen that I don't own. So we're going to keep on squeezing it. Now what I made is, let's see. This is silly putty, or it will be silly putty. Once let me squeeze it some more in there. Now, if it's still a little liquidy, still a little ooky, that means you just need to squeeze it some more. Otherwise, it might have a slime-like consistency. Some people call it oobleck, but it really is the color or the consistency of silly putty. And get back here. Okay, so now I've been squeezing this, and I squeeze this into this ball-type shape thing, and it's kind of like a rubber ball. So let's see if it does it. Ah! It even bounces. Ah! Come back here. Ah! And it bounces across the house. A great game to play at home, kids. Okay, yes. So what we did, we just created a polymer, and it flew off somewhere. Ball. Ah! Yeah, and it magically comes back to you. That's how cool this is. We just created a polymer. All the molecules are together, and you can make silly putty. Try putting this on a comic strip or a newspaper, or just make it into a ball, or just squeeze it if you ever get stressed, just like I am right now. Perfect stay-at-home science. Your freezer, you have ice. If you have a cup of ice and you leave it on your kitchen counter, what happens to it? It melts into water because it's wet. Now, hold that thought again. Except this ice is not wet. It is the opposite of wet. It is? Everybody say dry ice. Who has seen dry ice before? If everybody, good. Then what should I be doing if you know this much? Wearing gloves, yes. Why? Yeah, it can hurt. If it'll burn my hands. That's why I'm using safety gloves. It's not just cold, it's really cold. It's negative 109 degrees. It's so cold, if I touch it, it'll burn my hand. It's like sticking your hand in a 300-degree oven. So it's really cold. It's kept in this cooler. This is dry ice, which is made of the stuff you breathe out, which is carbon dioxide. Now, it's really cold, negative 109 degrees, and, yes. This is dry ice. It's melting. Is it turning into a liquid? No, it's turning into a gas. Everybody say sublimate. Sublimate is a cool science word. It means something's melting and going from a solid, not to a liquid like water, but to a, say gas. Yeah, it's turning into gas. So put that away because it's really cold. Now, who has seen a movie where you have a scientist or wizard, they're making all sorts of groovy potions? This is how they do that movie effect. We need, everybody say flask. This is my sidearm. See this arm coming out of the side? My sidearm flask. And this needs to go inside there, and it's not going to fit, so I need my special science tool, which is, yes, in science we use specialized measuring tools like the hammer. Okay, beautiful. You know what? I need a volunteer. Are you feeling brave? Come here. Nah. You look thirsty. Are you thirsty? Say, yes, I'm totally thirsty. Good, I believe you. Okay, good, because guess what you're going to do? You're going to drink my yummy, delicious potion. It tastes just like candy. You'll love it. And, it's tasty when it turns a nice, groovy blue color. And it's delicious. It tastes just like candy. So, open your mouth, stick out your tongue, and drink. Isn't it delicious? Drink it. Do you recognize the taste? Oh, wait, actually, we'll have people come up here. Anyone else want to drink it? Come on up. Get up here, get up here, get up here. Now, this is carbon dioxide, the same stuff that's in a carbonated soda. So some people taste get up here. Get over, have to pass this line. Get all the way up here, pass the line. Some people taste a Sprite or a Slice or a 7-Up. Does it taste just like candy? Or was I totally lying about that part? No. Yeah, no, it's disgusting. It's gross. Here, drink some more. You know when you drink a soda really fast and you have to burp? That's what this is, like drinking a burp. Here, drink a burp. Isn't that yummy? No, it's awful. Yeah, which is why I'm not doing it. So in our last segment, we created a polymer. Now we're going to, everybody say, destroy. Thank you, very verbal tech crew. You're doing great. Okay, so we're going to just destroy a polymer. The first thing we have is a, what is it, kids? It's a cup. We have a styrofoam cup. Now, what we're going to do, and then I need my acid, which is, everybody say acetone. Acetone is, you'll recognize the smell. It's that stuff in fingernail polish remover. Gross. So here's what we're going to do. We're going to hold one and put a little bit of the acetone on it. Hold the other side. Sorry about whoever's counter this is. You might want to put something on your counter when you're doing this at home. And then you pull and spread it apart. What's happening? You can totally see it disintegrating. It's breaking apart. It's the polymer that's locked in like this, breaking apart into this weird spiderwebby thing. And it's totally groovy. Let's see. And you can do this. So find all the styrofoam cups in your house, and you can do this with them. It's a lot of fun. That's lovely. Now, it's not limited to cups. Whatever you have in styrofoam. You guys have seen these before. Packing peanuts. Right now, they're on the inside of a glass. Usually, they're on an outside of the glass for packing. But we've got some styrofoam peanuts in there. And when I get them and you get them, we just throw them away in the trash can, and they fill up all the landfills. The only way to get rid of them, acetone. Oh, isn't that lovely? And who's thirsty? Wait, is this a good idea? Probably not. Oh, well. Well, we'll probably have... Ah! Ah! Okay, mop! Ah! So you might want to put something on the bottom of your counter like this so it doesn't get acid all over your friend's granite countertop. Okay, which brings me to my beautiful girlfriend Sheila. We're going to do the same thing with her, which is, remember this stuff? Acetone. Isn't she beautiful? Well, I think she's gorgeous, but everybody say makeover. Yes, we're going to give Sheila a makeover, basically the same thing. And like you've seen before, you can destroy a bunch of foam stuff you have lying around. You might have cups, you might have plates, you might have just a random countertop, or you might have my girlfriend Sheila. Let's just fix her eyes, make her even more beautiful than she is. Yes! Isn't she lovely? Let's fix her lips. Yes. Nice. Everybody say nose job. Nose job. Oh, that's just perfect. Give her a little bit in the ears there. And isn't she nice and lovely? You can, wow, perfect. Yes, just like prom all over again. So you can have things like this, fun science. And you know what? Leave this and come back in about 20 minutes. You can touch it. It's really soft and really groovy. Not right now because it's kind of, you might not want to touch it right now. But come back at the end of the show and touch your foam head, and it's really groovy. Now, final quiz on this stuff. It is dry ice. This is my favorite potion ever. Dry ice made of the stuff you breathe out, which is carbon dioxide. Did I say how cold it was? Yes. How cold is it? It's negative 109 degrees, but I'll accept really cold as an answer. Okay, I need my special ingredient. Everybody say green. Green. Once again, precisely measured. Squirt. And give me a countdown. In 5, 4, 3, 2, 1. And somebody come here if you want a bubble bath. Come here, quick. Take it. It's hot like well. Here, hold this. If you're worried about germs, it's totally, my secret ingredient is soap. It's Dawn dishwashing liquid, which is why you all smell like green apple. Take it. There. I know. It'll smell like my dishes. So adults, if you want to try this at home, what we're using is dry ice. I'm using boiling water to make the reaction go quicker, but if you do that in a normal glass, it'll probably shatter. So anybody done this for Halloween? Make some cool potions. So this is lab glass, and this will go on a long time because I didn't measure my ingredients. It should have stopped by now. And it's not going to stop. Okay, welcome back. Now here's a great activity for something you can play with outside. We are going to make bubble solution. Everybody loves bubbles, and they're really simple to make. All you need is 3 ingredients, but we're kind of specific on what they need to be, so let's walk through it. First thing is water, not just any water. You want to use distilled water. Now, I've got, about 12 cups, so roughly about 3,000 milliliters, 2880 milliliters of distilled water. I'll be giving you the measurements both in cups and milliliters, depending on what you happen to have lying around in your kitchen. So, dump this out. And usually we just kind of dump out our ingredients in my shows, but now I kind of want to make this work, so I thought I'd measure it and see what happens. Let's see. That's good. Next we have soap. Dawn dishwashing liquid is your best bet. If you can't find this, go for Joy dishwashing liquid, but really Dawn's the best one. Now we need, about 240 milliliters, basically a cup, easy enough, a cup of soap. Dump that in there. That's about 240-ish. That may be a bit too much, but it'll work. Now, our next ingredient, number 3, this is important. This is glycerin. Vegetable glycerin is what I'm using. You can find this at any drugstore. Let's see. I'm just going to, this is about 300 milliliters. If I get it right to the top, that should be good. Now, we're using glycerin. Glycerin makes it thicker, so the bubbles will be stronger and they won't pop right away. Squeeze. And dump it in. Now, let's see. We got to mix this all in. This is one of the experiments you might want to do outside again. Now, for mixing, we can use our fingers or this thing. Let's see. Mix it gently because you don't want to overflow with a bunch of suds like a big bubble bath because that makes it harder to get the actual bubbles. Now here's what we're going to do. Now what I've done is I've made, see all these things? These are coat hangers. I've taken and bent some coat hangers, and I've wrapped some string around the end. You can just make a coat hanger and make a nice big loop like this. Going to make our coat hanger bubble wand. Stick it in, and you go. Now I added string, so hopefully that'll, help absorb the soap. And when you take it out, let's see. Ah! Nah! Magic giant bubbles. And you know what? You don't even need to go outside to do this. Do it inside. Do it in your kitchen, just like this, or better yet, your friend's kitchen, just like I am. Perfect bubble magic with the Science Wizard. Oh, wait, here. Face them and take a deep breath. Let it out. Okay, when you take a deep breath, a couple things happen. Your shoulders go up, and there's a muscle right here called the diaphragm that goes down. Your lungs act like a vortex. Now, you can sort of see it there, but to really see it, we need the air zuka, which is, okay, here. Take this and go shoot them. Grab here, go over there, and go over there and shoot them. Okay. Now, it's really, what shape is it again? Who told me? Circle like a basketball or circle like a donut? Well, we're going to find out, but you can't really see it there because air's invisible. Come here. And this is really too small, so we need the Big Mama Vortex. Okay, here's what we're going to do. Hang on to that. And I'm going to need you to help me angle it. We're going to fill this up with fog so you can actually see what's going on inside. It's going to be like being out on a foggy day. Come this way. Now hold it right like that. Let's see, you can get a nice foggy day. 5, 4, 3, 2, 1. And let's see. What shape is it?
What shape is it?
Circle. Ah! This is nice. I'm not worried about setting off any smoke detectors here. This is great. Yeah, circle like a donut. You can sort of see it. Look real close. Give a round of applause for getting shot in the face like that. That was very nice. Have a seat. Perfect. Welcome back. Well, if you thought the last experiment was messy and chaotic, just wait for this one. Another experiment that you should probably do outside. But we're going to do it inside. Today we're going to make quicksand. And for quicksand, it's something, again, you probably already have in your kitchen right now. 2 basic ingredients. Our first is cornstarch. Now, the ratio is really simple, 2 to 1. 2 parts cornstarch for 1 part water. Let's see. Now, you don't have to measure, but, let's just try measuring just for fun, just to see what it's like. I'll just fill this up, basically. This is 600 milliliters, give or take. That's probably a little much. Doesn't matter. Dump that in. Perfect. And now our next ingredients, water, 300 milliliters. Again, a 2 to 1 ratio, roughly. Now, the thing about this is we're just going to mix with our hands. This is hands-on science. We are making quicksand, which is a non-Newtonian fluid. That means it has the properties of both a solid and a liquid. So if it's too liquidy, you could add more cornstarch. If it's too solidy, you can add more water. Little technical science terms for you. Now, so I'm mixing this up really, really well. You can see my clear bowl. Now, it's very liquidy. It looks kind of milky, but it's kind of, I got to stir it in there. I mean, you add some more cornstarch. Let's dump some more in there to get it more clumpy. If you want it more clumpy, add more clumpiness, which is cornstarch. And again, you probably have this in your house. If not, go to the baking aisle at any store. Really cheap stuff. And I'm starting to make a little mess. So newspaper, you can line your counters with newspaper if you have newspaper. Anybody know what those are? Or take it outside. Squeeze. Oh, that's gross. And then when you take it out, this is the solid I was talking about. Oh, yeah. It's actually a solid right there. Non-Newtonian. A solid and a liquid. Now, you probably don't have, well, you might have quicksand in your backyard. If you were watching cartoons, you probably thought it existed everywhere. This is how you get out of quicksand if in the unlikely event you find yourself inside it. So I'm putting my hand in there super flat. If you try to yank it out quickly, you get stuck and it won't come out. I can barely move it. But if you ease it out, you can ease it out slowly and ooze it out. Yes, then I can escape the quicksand and, well, isn't that disgusting? That's why you want to probably be doing this outside. And then you can play all sorts of games like, hey, let's see you can get trapped in the quicksand. and then grab it and squeeze it. And really, it's very simple, but you can spend hours just doing this and squeezing. I'm going to go outside with this. Take another deep breath. Let it out. What do you breathe in? Oxygen. That's a trick question, because really your body uses oxygen, but you breathe in whatever's in front of you. Any there is in front of you, and most of the air on Earth is not oxygen. It's not carbon dioxide. Most of the air on Earth is, who knows? Everybody say nitrogen. Most of the air is nitrogen. Now, this is important. If you are in your kitchen and you're heating up water on a stove, what happens to it? It bubbles. It starts to bubble and turns from a liquid into a, say, gas. Yeah, evaporates, turns into a gas. If you take that same gas, that same water vapor, and you cool it back down, it goes from a gas back into a liquid. Okay, so here's what we did. We took all this nitrogen and cooled it way, way down, and turned it from a gas into a, say, liquid. Liquid, yes. And we made, say, liquid nitrogen. Yes. And it's kept in this big thermos-looking thing called a dewar. This is liquid nitrogen. I'm going to dump stuff out. What color is it going to be? Clear. What color is nitrogen now? It's clear. So we're going to dump this out. I'm going to pour it out.
Oh my God.
What would happen if you touched one of those little bubbles? Actually, not really, because your skin is so hot, it would instantly turn it to gas. Now, if you see, can you see if you can see? You'll see the smoke. You see the little bubbles also? Little bubbles like that, yeah. It's like when you put like a few droplets of water on a really hot skillet. That's the same effect, because it's so cold in here, negative 321 degrees, and it's so hot out here with the pavement. Now, like I said, we're going to turn this from a liquid into let's turn it from liquid back into a gas, because you can see it turning into gas right here. If you want to speed up that process, just like that. Now, when people get really cold, they get close together. Take one step towards the middle. Take one step towards the middle. Take one step towards the middle. Okay? They get closer together. Just like air molecules, they do the same thing when they get cold. Now, when people get hot, wait, we're hot, spread apart, spread apart. When you're hot, you don't want anybody near you, you want your own space. Just like air molecules when they get warm. Wait, we're cold again, step one forward. See, when we're cold, we get together, and we're hot, spread apart, spread apart. Everybody got it? Hey, how many balloons can I stick inside my bowl? One, unless I pop them, and that's cheating. But if I add, where'd it go? Here it is. If I add nitrogen, oh, it's okay, I've got more. Oh, by the way, what should I probably be doing about now? Gloves, yeah, is this cold or crazy cold? Crazy cold, so I'm going to use some gloves here. Now, here, give me a balloon. Balloon. What's happening to my balloon? It's shrinking. Other balloon. Give me more balloons. Go. It's shrinking. Remember our little demonstration? What's happening to the air molecules? When air molecules get cold, they crush in together like that. Balloon. So the balloon isn't popping. It's still there. All the air is still inside. It's just getting really, really close together. How many balloons can we fit in here? All of them. Probably tons. Probably a lot if they didn't already run away. Okay. Actually, don't worry. I still need you. So here, take this and put this on your left hand. Take this and put it on your right hand. And come over here, please. No, you stand over there. We'll do it on both sides. Now, hold your hand out like this. Like this. Now, all the air, I'm obviously not touching the nitrogen, otherwise I'd be totally screaming. All the air is in there. As it warms up, it starts to reinflate. That's just the air molecules spreading apart, because I need you to hold that. Hold. Now, if you blow on it, it'll happen quicker. And we're going to go out here. Here, blow on these. From a distance, so you're not blowing anybody else. Yeah, and that'll happen invariably. When you get it cold, the air molecules go together. When they warm up, they spread apart, and it appears to reinflate. And that's good enough. Give my balloon wranglers a round of applause for coming up and doing that. Balloons, run for your lives. Okay, so you recognize this is the balloon just filled with normal air, but you've probably seen these at your birthday party where they float in the air. Those are helium balloons. Now, you might have seen the blimp, that big ship that flies over football games and takes pictures. That's filled with helium also. It's filled and then it floats in the air really nicely. But a long time ago, they didn't use helium. They used the lightest gas we have, which is lighter than helium. They used hydrogen. Hydrogen is the #1 lightest gas we have. But they don't use hydrogen for blimps anymore. I wonder why. Let's find out. Hey kids, welcome back. Now the question I get asked most frequently when I come somewhere is, hey Science Wizard, are you going to blow something up? Well, of course, that's why I'm here. But today's segment is all about kitchen science, things you can do at home. So do not do this at home. Don't try this at home. But I am going to blow something up with ingredients I found right here in the kitchen. Our first ingredient is, let's see, this is aluminum foil, tin foil. If you're really old, you might call it that. I need some of this. So what I'm going to do, take off some tin foil and just crumple it up in some little balls. I'm going to need the aluminum for this next reaction. And next we have NaOH, sodium hydroxide. This is drain cleaner. It's lye. Let's see. We're going to add some lye. What did we learn about measuring our ingredients? We should always measure? Well, whatever. Okay, dump some in there. Oh, that reminds me. Nah. Hey, have I been wearing safety glasses yet? No, but I'm wearing them now. What does that tell you about this next demonstration? Let's see. So, safety glasses on. We've got the sodium hydroxide. And put that in there. Now, we're going to add some water, H2O water. Now, this is going to give us an exothermic reaction. Exothermic means it's giving off heat. So, I'm going to dump that in there. And that's only a little bit. You know, I might need some more water. Get my emergency reserve of water, just for fun. Nah, that's probably good. Now, swirl this up. Oh, that's really warm. This is giving an exothermic reaction. It's giving off heat right now. Pretty soon it's going to be too hot to touch. So we're having this reaction right now. And it's hot at the moment, but it's going to get really hot. Let's see. Yes, and, here we are. Gloves, safety gloves, because safety is, my #1 priority. It's in the top 5. It's up there, but it's significant enough that I'm going to wear these gloves because it's going to be super hot. Now, let's see. I've got the sodium hydroxide, and now it's time for... All right, get the foil. Get in there. Now, oh my gosh, it's starting to bubble. I need this glove on because I got to put this balloon on. It's starting to bubble. Now, it's giving off hydrogen gas. We are making a hydrogen balloon. And oh my gosh, that's happening so fast. I didn't think it'd go this fast. I'm putting on gloves because that's going to be not just hot, but crazy hot. And, okay. Now, I got to tie this balloon, which I can't do with gloves on. Ouch! Hey, is it hot or am I just teasing? It's crazy hot. Look at that thing bubble. Okay, so now we got to blow. Oh, here. I need disembodied hand. Come here. Get over here. Quick. Okay, here. Now we're going to take this up. Remember, this balloon is filled with hydrogen. Remember that blimp? Let's see. This is why we don't use hydrogen in our blimps anymore. Let's bring this. Come on, coward, bring it all over here. And it's not working. Okay, what a fun game to play. Don't try that at home. Oh my gosh. Thank you so much. Whoops. Somebody get the ceiling. We'll be right back. Hey, by the way, should you touch the nitrogen? No, it's a terrible idea. And to prove that, I've got my brave volunteers who wants to be a volunteer to touch the nitrogen. Oh my gosh, you don't want to touch the nitrogen? Which is why I'm using, say hi, beach ducky. Beach ducky can't go to the beach anyway, so in you go. And I don't know what kind of ducky this is. This is, pirate ducky. Pirate ducky, in you go. And let's get more nitrogen in there. Hey, once again, chemistry, do we measure it or just dump it in? Dump it in! That's kind of what we're doing here. That's a lot. Now, hey, what am I doing now? Have I been wearing glasses yet today? No. But I'm wearing them now. What does that tell you about these experiments? Yes. Also, we have bouncy ball. And, I forgot. I was going to ask for some fruit. But I don't need fruit. Because I have, my sweet, beautiful roses. In you go, roses. Now, this is getting really, really, really cold. Am I really cold? I mean, so cold I don't want to touch it. Now, anybody ever watch any of those competitive cooking shows? Ah! What just happened? A ducky exploded. That's what happened. Sorry, ducky who exploded. It was the pirate ducky. Sorry, pirate ducky. In those shows, they have a blaster that gets something really cold really fast, and they don't do rubber duckies because they shatter. Okay. It only takes a few seconds, really. Oh, look at my nice, pretty rose. Now, ah, it explodes. Look out! Who wants an exploding rose? Me. Exploding rose! Ah! Here we go. Exploding roses! Ah! Oh, my ducky. Sweet little beach ducky. Now, the other pirate. Okay. Who's going to win the battle between Mr. Ducky and Mr. Hammer?
Oh, okay, obviously.
Well, let's see. It was the hammer. Oh my gosh, I forgot the main course. Everybody say hi, giblets. Say bye, giblets. In you go, giblets. Get in there, giblets. And one more time for exploding roses. If you want to explode rose, get up to that line right there. That's good. Actually, get up to this line right here. 3, 2, 1. Ah! Look out! It's raining roses. Somebody squeeze them. Destroy them. Okay, back to your seat, back to your seat. My roses!
This is so cold.
I'm gonna need a broom after this. Okay.
Oh my god.
What else is in here? Who remembers? Bouncy ball!
Yeah.
Ah! My bouncy ball! Yeah, you can see these things get so cold, they get all brittle and they shatter. Ah! I think that was the chicken. Sorry, giblets. Oh, wait. What? Ah! My chicken! Ah! Okay. You get out here. Okay, now most of those things are made really brittle, but what's this? Now, this made it, there's a lot of liquid in there, so it made it hard and strong. It's so strong, it's as strong as this device. Everybody say banana hammer.
Banana hammer.
It's such a strong hammer, strong enough to hammer this nail in this piece of wood by just being a banana.
Oh my god.
Ah, totally, oh, whoops. Well, if you run out of hammers, that's why you do that, so you just use your banana. Oh, you can see right there, it still hasn't frozen through. So if you stick your tongue right in that spot, you wouldn't get frozen. Who wants to try?
Me.
Oh my gosh, what's wrong with you? That's a terrible idea. If you missed, then the rest of the banana would do what? It would freeze and stay on your tongue, and you'd have banana tongue all day long. So you don't want that. And now one more thing, what's left in here? Get up. Oh gosh. Giblets! Okay, we're going to do it right here. And give me a countdown. 5, 4, 3, 2, 1, and... Ah. Final quiz. What's this stuff? Liquid what? Say nitrogen. It's really cold. How cold is it?
Really cold.
Really cold.
Crazy cold.
I don't use Celsius. I'm not Canadian. Yes, negative 321 degrees Fahrenheit. And let's see, where's the wind blowing? Right towards that guy. Is that good or bad? Bad or terrible, probably. Let's see. Terrible. Let's see. Well, now it's blowing towards me. That's even worse. There's really no good way to do this. Okay. What was the first thing we did with the nitrogen? Who remembers?
Hot water.
Hot water, turning it from a liquid into a, say gas. Okay. So take a look at the smoke, see which way the wind blows, and which way should I run for my life? That way? Okay, here we go. Give me a countdown in 5, 4, 3, 2, 1. Ah! Yes! Come up to the line. Come up to the line.
No way.
Quick. Now blow inside. Don't put your hands in now. Blow inside and blow your face off. Isn't that cool?
A piece of a lava chicken.
Oh my gosh, my chicken carcasses. Leave it there.
Oh, yummy.
It's yummy. Weird. Yeah, if you blow straight in like, ah! That's nice and cold. Hey, welcome back. So now you're probably wondering, you know, this is really fun stuff, but are there any explosions I can do inside? Well, sure you can, although you could probably do them outside, might be wiser, but we're going to be inside right now because, like I mentioned, it's not really my kitchen. So the first thing you need for this explosion is film canisters. Back in the olden days, we used something called film, and you'd stick film in there, which isn't really important now. So you want to find these if you can. Now here's the trick. Take it, you got to be able to put the lid on really quickly and tight, like that, so it snaps. Let me take it out. Yeah, really tight, so it snaps. Once you've developed that skill, you're ready for the next part. Next thing we need is, take a deep breath, let it out. We breathe in oxygen, and we breathe out carbon dioxide. These are carbon dioxide tablets. Look in your dad's medicine cabinet, kind of like a, you know, Alka-Seltzer, basically. Little tablet. It takes about a quarter tablet to make this work. So we're going to use a whole tablet. What could go wrong? Okay, perfect. So we're going to add this, and we're going to add some water into it and shut it up really quickly. Now this PVC pipe, this is my going to be my launching tube here. If I aim it there, it's going to go right at the ceiling, and we'll probably make a mark. And I can't aim behind me, so we're going to go right for the camera that I also don't own and see what happens there. So add a little water. Oh, it's fizzy. Okay, with the lid on tight. Now put it upside down inside your firing tube. Now this is a great game of catch to play with someone. Have someone stand right about there, about 25 yards, and say, okay, open your eye sockets really wide, and then, ah! Oh my gosh! Wow! What did that, was that the ceiling fan? If it got darker, one of the light bulbs may or may not have gone out. Okay, so you want to be careful when you aim that. But in the meantime, quick, before the authorities come, let's do another one. Okay, so remember, Alka-Seltzer, tablet, half tablet, pour some water in there, about half full. Put the lid in there. Now, you can use PVC pipe to aim it, or if you're really brave, you can just use, you know, part of your body, like your hand here. Which, I don't think I want to do this, but... Or it might not work at all. That's the thing about science. We're experimenting, and I don't know. I kind of wish I'd used the PVC pipe at this point, but... Ah! Oh, geez, was that the family heirloom? Oh, okay, sorry about... Okay, well, kids, why don't you take this experiment outside? This is a great experiment for outside in the backyard, maybe where there's no heirlooms or ceiling fans or, you know, multi-$1,000 cameras. And great experiment to try at home, kids. Hey, who tasted the dry ice? If you tasted the dry ice, did you taste the soda at all? Anybody? Dry ice is carbon dioxide, the same stuff in a carbonated soda. Just like one of these. It's carbon dioxide that makes it carbonated, gives it all the bubbles. What happens if I shake this up? It explodes. Are we going to shake it up? No, we're not going to shake it up. That's not scientific. What's the scientific way? Mentos. Yes, yes, yes. Who has seen the Mentos experiment? Who has actually done the Mentos experiment? If you've actually done the Mentos experiment, how many Mentos does it take? Just like one or two, really. How many are we going to use? All of them. Yes, you were paying attention. We're going to use them all. Make sure, let's see, where am I going to be? I don't know. Okay. We're going to use them all. By the way, adults want to do this. Want to use the mint-flavored Mentos because the other ones have a different exterior coating. Doesn't work as well. Mint-flavored Mentos. What's this? Root beer. Oh, specifically? Diet. Why diet? Anybody know? Has no sugar, which means if I spill a drop or two, there's no sticky mess. You really should go back further. Trust me on this one. Don't try and catch it in your mouth. Gross. Oh, and by the way, I shouldn't have to say this. Don't come up and lick the table. This is no matter how tasty it looks, don't lick the table. It's gross. Okay. I don't know, but people do every time. Okay. It's not sticky. It's just, okay, where's it going to go? Make sure it's fresh. Listen up. I'm here. Yes, don't fizz. Don't fizz! I just bought this today. Blasted fizziness. Okay. Ah! Ah! Does it smell good? It's nothing like the lovely smell of diet sodas. Okay. Between that and the green apple smell of the soap, where am I running? Towards you. Okay, give me a countdown in 5, 4, 3, 2, 1. Is it gonna work? Ah! Look out! Don't get out! Gross! I mean, what? Oh, that was cool. Who wants to try it one more time? Let's try it one more time. Okay. Final quiz. What's this? Any sort of diet soda will work. I'm using root beer because I think it's the fizziest, but any sort of Coke, Pepsi, any diet soda will work. Next we have what? Mentos. What flavor specifically? Mint flavor Mentos. That's important. Don't fizz. Don't fizz. Don't. Wasn't supposed to fizz. Okay. It's all soapy. Okay. Oh, one Mento would totally work, but that's why we're using all of them. Final countdown in 5, 4, 3, 2, 1. Work. Ah! This is, everybody say windbag. I am going to fill this windbag up with my breath. Here, somebody hold this. Just hold this right there. Now, and 4 breaths. Here we go. Gotta fill it up, and... Oh, we forgot to use science. Everybody say Bernoulli's. We're gonna use Bernoulli's principle, and here's the deal. Now, who was paying attention? I filled it up. Where is my mouth? Put it back. My mouth was right on the top of it. Grab it. If my mouth is right on top, just like that. You hung on this time. Now, only the air from my lungs got in there, which is why I barely filled up at all. But here's what we're gonna do. I'm gonna back up, and we're going to use Bernoulli's principle, and my air is going to go in, but that's low air pressure. All this air pressure from outside is going to come and fill up this windbag. Like that. Yes! Do I have that much air in my lungs? No, I don't have that much air in my lungs. But that's using Bernoulli's principle, totally filled up. Now, there's a way you can demonstrate that at home. But my breath isn't strong enough, so I need... Yes! Don't laugh at that! Okay. I need a volunteer. Let's see. Okay. Stay there. Here's what we're going to do. Where is it? Hold. Yeah, you know what this is worth in the black market? Oh my gosh. Okay, hang on to this. I know, $1,000. This is like the most expensive experiment I've ever done. Here. Hang on to it. You had one job. Here, stand over there. In toilet paper holding. Okay. In there. Should go this way. Always goes over the top. Hold out both hands. It is. Let's see. This is fun because this is a great experiment you could do at home. Okay, here, get over here. Hold this. All you have to do is not let go. Come back a little bit. And I might point you this way, or for fun, I might point you that guy over there and make me laugh. And we're going to see. But I need, now, hold on really tight because it gets windy. Everybody say, I promise to try this at home. Here we go. Woo! There we are. And we're going to waste the whole roll. And there we are. Instant mummification. Thank you guys so much for coming. If you have any toilet paper, do we have a trash can anywhere around here? Hey kids, thank you so much for joining me for this super fun kitchen science. Hope you enjoyed this. Hope you enjoyed the show and got to watch them both. I'm sorry I couldn't come down there to see you, but when all this is over with, I'll be there in the fall or maybe next summer for the summer reading program. In the meantime, do science boldly, always with an adult, a parent, a teacher, a librarian, somebody who at least owns a lab coat for crying out loud. Thank you for watching, and I will see you next time. Bye-bye. I'm going to clean up the backyard now. Oh my goodness. Okay, final quiz. One more thing. Let's see. Finish this science quote. For every action, there is an equal but opposite reaction. So the action was the liquid went where? That means the reaction, the force of the bottle went where? Down. What would happen if we flipped it? Well, let's find out.
What? You're crazy.
I'm not crazy because I'm not going to do it. I need a volunteer to do it, though. You know what? Everybody form a line back there if you're going to. All the way down, but not yet. Hey, who's launched water rockets before? No one, just a few of them. Okay. Basically, it's really simple. You just need some water in a 2-liter bottle, an air pump. This is just PVC pipe hooked together, and that's it. If you're really good at this sort of thing, you have a launch string, which is a safety string that you can pull from a safe distance and have your face out of the way. What part am I missing? You see a safety string? No. Is that a problem? Well, you're just going to pump and you're going to run, but I'm going to hold it here until I run for my life. Okay, here. So all the way up, all the way down, and all the way down, go, and then someone else, go. Next person, quick. All the way up, all the way down, all the way down. Yes, we're filling up with air. It's going to get harder and harder and harder every time. Go. As we fill it up with air pressure, oh my gosh, I can't believe one person can still do it. Okay, next person, quick. All the way up, all the way down. Oh gosh, last one. Okay, next one's going to be 2 people. 2 people, next one. It's too hard for one person. Yes, excellent. 2 people, 10 times. All the way up, all the way down. How'd you get? Go. Oh, quick, look out, go. 3. No, it's going to blow up. 3, 2, 1, look out. Run for your lives. All right. Okay, line.